Okay, welcome to my presentation. I'm going to show you my solution in AWS to a requirement from a small business with a 3-tier web application who need a VPC. So here you can see the brief on the VPC we were asked to design and deploy. And as you can see in my solution diagram here, it's a multi-tier application within a VPC spanning 2 availability zones. It has 2 public subnets to hold the NAT gateways and the initial EC2 instances, which were set up to test the deployment configuration was working as it should be. Then there's the web tier, the app tier, and finally the data tier at the bottom, all in private subnets. Private subnets are then associated with the private route tables, which route internet-bound traffic to the NAT gateway, while the public subnets are associated with the public route table directing internet-bound traffic to the internet gateway. The architecture also has 2 load balancers, the web LB handling traffic to the web tier, and the app LB handling traffic to the app tier, distributing it between the instances. It also features 2 auto-scaling groups, with the web and app auto-scaling group set to maintain a minimum of 2 instances, and also to increase capacity in response to a dynamic scaling policy target metric based on a preferred average CPU utilization of 60%. Finally, the architecture features 5 security groups, with the 2 load balancers having 1 each and the private subnets at each tier also being enclosed in security groups. The groups are chained to allow only inbound traffic from the security group above. For example, the web security group accepts traffic from the web LB security group only. And this is for security purposes to prevent the entire system being at risk should one tier be breached. Now, some of the design decisions I made in the course of this assignment. RDS was a good choice for a scalable database as it has built-in replication functionality. It can be promoted as a standalone instance if there was a disaster. It also allows cross-region backup replication, and you can scale it vertically by changing the instance class. The brief called for 256 IP addresses per subnet. Best practice VPC design would state that some address space should be held for future use to allow for future availability and scalability. So I set an IP address CIDR block of 10.0.0.0/20 on the VPC, which comfortably allows the 256 IPs per subnet and gives room for future growth. Load balancing and auto scaling. So my architecture builds in availability here by deploying resources in multiple availability zones with load balancers to prevent against failure in one geographic region. And it also uses auto scaling groups for the web and app tiers with dynamic scaling policies to ensure the minimum and desired computing capacity is maintained and that the system can balance the workload amongst the deployed resources. And then to ensure the security of the data in the data tier and to prevent any breach of data at the public subnet area from spreading throughout the VPC. Security group chaining was a great option here, and so each tier has a separate security group set up to enclose its subnets, as does each load balancer. And the public subnets are the only tier with direct access to the internet gateway through the public route table, and all the private subnets are connected to the private route table and the NAT gateway. And this ensures the security of the instances in the private subnets and ensures they do not have access to the internet. They do have access to the internet to receive patches for any updates. So I'll now switch over to the AWS console to actually show the deployed resources. Okay, so I'm here in the AWS console now, and you can see my VPC here, project VPC. I'll show you the subnets, which are part of that. So these are the subnets, and you can see the associated CIDR blocks there. You can see they're all project VPC. Now I'll go to the route table, so you can see here in the public route table, and the routes there directing to the internet gateway, and the subnets associated being the public subnets. And here if we flick into the private route table again, then you can see that that's directing to the NAT gateway and associated with the private route tables. I'll very quickly go to the security groups. So you can see my security groups here, and to demonstrate the security group training, I'll just go to the web security group here, so you can see on the inbound rules that is accepting traffic from the web load balancer security group there. Now I'll go to the EC2 instances, and we can look at the auto scaling groups and the load balancers. So in terms of the auto scaling groups here, just to give you an example, the web auto scaling groups, you can see the desired capacity, minimum and maximum that's been set there, as well as the dynamic scaling policy based on maintaining an average CPU utilization at 60. Here you've got the load balancers. Two load balancers there, the app LB and the web LB. And now I'll just show the instances. So I have a number of instances here that were terminated from earlier tests, but I've got 1, 2, 3, 4 running instances, 2 at each tier. And finally, I'll just go to the load balancer. I'll go to the web load balancer, take the DNS, and we can see this page here. And finally, just to perform a quick test on that, on the load balancer and the auto scaling groups, that they're working correctly, I will terminate one of the instances. And that should shortly regenerate a further instance in its place to maintain the desired capacity of 2. So you can see there that it's been terminated. And you can see now that one has come back in its place there, that one is just flicked over from pending back to running. So you can see that the load balancer and auto scaling groups are working correctly there.